Okay, let's go over some equations and testing if a point that's given is a solution to that equation or not. Well, this is kind of a review from our graphing, but in our coordinate points, we have an x value and we have a y value. It's important that you make sure you label which one's x and which one's y because that's exactly what you're going to plug that number in for. So I'm going to substitute -5 for all of the x values in this equation. And I'm going to substitute 7 for all of the y values in this equation. And then I'm going to see if this statement's still true. If it's true, then it's a solution to the equation. If it's not, we would say it's not a solution. So this is what that looks like. I'm going to take this exact same equation and I'm going to write it here. But I know that instead of x, I have -5 for my x value. This is very important. When you substitute, you have to put parentheses around whatever you substitute in. So I'm substituting x with -5. So I need to put parentheses around the -5. Same with y. Now instead of y, I have 7. I'm substituting that in, so I need parentheses around it. Now this statement says 2 times -5 plus 3 times 7 equals 18. So let's see if that statement's actually true. 2 times -5 is -10. 3 times 7 is 21. And we want to see if this equals 18. I like to do this and go, question mark. We don't know yet. We still don't know if it equals 18. We're testing this out. We don't know yet. We don't know if this is a true statement yet. Now, is 21 minus 10 or -10 plus 21 18? It is not. It is 11. Which is definitely not 18. So in math, this kind of drives me nuts to actually write this because this is not a true statement. This is not equal. So in math, how we say not equal is we put a little slash through this equal sign. So we're saying 11 does not equal 18. So we know that -5, 7 is not a solution to the equation 2x plus 3y equals 18. That would be my conclusion because this was not a true statement. This was false. Okay, so let's go ahead and do another one. We're going to do the same thing, but now x is 3 and y is 4. So I'm going to write my equation. And this is how I would suggest writing this every time. I know it's a pain to erase x, and I know it's a pain to erase y, but the chances of you making a mistake are so much less if you do it this way, if you haven't been just getting them right over and over and over again. So I'm going to erase x, and instead of x, I'm going to write a 3 in parentheses. And I'm going to erase y, and instead of a y, I'm going to put a 4 in parentheses. Now this says 2 times 3 plus 3 times 4 equals 18. So let's test it out and see if it's true. 2 times 3 is 6. 3 times 4 is 12. We're wanting to see if this is 18. And 6 plus 12 is, in fact, 18. Notice I did not do anything to the right side of this equation. I just left it alone. And I want to do that. I don't want to move things over this equals sign. I know you've solved equations in the past and you add and subtract to both sides. You multiply and divide by both sides. Do not do that. Everything that's on the left, keep it on the left. Everything that's on the right, keep it on the right. Because we want to see if those statements are actually true, if they are actually equal to each other. This one was true. So we would say 3, 4 is a solution to 2x plus 3y equals 18. Now, I'm going to put another one up here. This one is y equals 7x minus 2, and you have two solutions to test out here and see if they actually work. Remember, do not move anything over that equal sign. We're just simplifying on each side and leaving it on that side to see if those two things actually do equal. So go ahead and pause the video, and then when you're done, press play and you can check your answers. Okay, So in this case, x is -1 and y is -9. I'm going to write my equation just as it is. This is the equation that was given to me. But now we have y over here, and instead of y, we have -9. I don't technically need my parentheses here, but I'll write them here just so that you get in the habit of doing that. And x is -1, right? So let's simplify on each side of this, and we want to see if this actually is true, if these two sides really do equal each other. -9 is just -9. And we want to see if it equals this stuff on the right-hand side. So 7 times -1 is -7, and we still have a -2. We still have -9 over here. We're wanting to see if it equals. And -7 minus 2, if you owe somebody $7 and you spend 2 more, we still owe them $9. So this statement is actually true. So your conclusion should be -1, -9 is a solution to y equals 7x minus 2. And if you were to graph this equation, you would see that that point is in fact on that line, that the point -1, -9 is on the line. So let's test the other one. We have x is 0, y is 2. I really want you to pay attention how I'm organizing my work because this is how I should see it on a test when I'm checking your work. So we're going to write y equals 7x minus 2. And instead of y, I have 2. And instead of x, I have 0. And we want to see if these are equal. This side, we just have 2. On the other side, I have 7 times 0, which is 0, and then we have a minus 2. And 0 minus 2 is just -2. This is not a true statement. This is false. And I have to put the not equal to here. I just can't leave it like that. So I would say that 0, 2 is not a solution to y equals 7x minus 2. And that would be my conclusion.